in 1995, people came up with a specific algorithm called as Adaboost. And adaptive boosting. Adaboost stands for adaptive boosting. Okay. So let's get into the algorithm and then let me explain. Suppose you have 10 observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Say you have 10 observations. And let me draw the diagram here for easy processing. Say you have two inputs, x1 and x2. Given these two inputs, say you have two class problem. One is, I would call it as pink class, another as maybe blue class, right? So first, let me come up with a blue class. Say you have P1, first data point, or let me call it as serial number 1. Then say you have serial number 2. Say you have serial number 3, serial number 4, serial number 5. So you have 5 data points, 1, 2, 3, 4, 5. And another 5 belong to a pink class. S6, S7, S8, say you have S9, and say you have S10. The reason why I'm listing down the points in this way is because I want to explain you in a detailed manner on how it works. At the very first stage, every data point is given equal weightage. Every data point is given equal weightage at first step. Initialize all the training samples with equal weights. Since you have 10 points, each data point is given a weightage of 0.1. Since you have 10 points, each is given a weightage of 0.1. So it'd be 1 divided by n. This is the weightage which is given to each point, where n is equal to number of data points. If you have 10 data points, n will be equivalent to 10. And 1 by 10 will be 0.1. So each and every observation, each and every row that you're going to have will have a weightage of 0.1. Is this part clear? 1. Next, what happens? You build your classification algorithm. Okay, when you build your classification algorithm, assume that your classifier was like this. This is your iteration 1. In iteration 1, you have these two observations and the other observations. So this is something like this. Anything which falls on the left side belongs to blue class. Anything which falls on the right side of this classifier belongs to pink class. Then how many data points will be misclassified? Correct. 3 data points will be misclassified, which happen to be S3, S4, and S5. These 3 will be misclassified. Okay. The moment these 3 are misclassified, you need to assign weightage to them. Because it is boosting, what boosting does is it will look at the misclassified entries of the previous algorithm and it will give it more weightage. If it is given more weightage, the chances of those getting picked up in the training data will be more. Here, since weightage is equal to every data point, when you randomly split it into training and test, every observation has equal chance of being in training and every observation has equal chance of being in test. After the iteration 1, since 3 points, serial number 3, 4, and 5 are misclassified, you need to assign them more weight, more weightage. Why will some point be misclassified? Because your algorithm didn't learn it properly. Since it did not learn it properly, you want to include that in the training data. And you want high weightage to be given to misclassified entries. Simple logic. So here there are 3 steps, friends. One is that's okay. Or let me write down the formulae, 3 formulae, and then I'll explain about them. This is how the formula is started. Okay, how do I put it? Let me put it as error. Error of the model is equal to average of all the misclassified entries. What were the misclassified entries? These 3, right? So initially, the weightage given to that is 0.1, 0.1, 0.1, these 3. So you take 0.1 plus 0.1 plus 0.1 divided by overall summation. Summation of all these. Summation of all these weights, when you add, what will you get? 1. Summation, not average. Add all these 0.1, 0.1, etc. You get 1. So this will give you 0.3. Once you get this, you need to calculate something called as alpha. Okay. This alpha formula is half into log of 1 minus En divided by En, which is nothing but half into log of 1 minus 0.3 divided by 0.3. When you solve it, you get 0.42. Okay, don't assume that I'm doing super fast calculations. These are the numbers which are already written. Okay. Next, if you want to calculate the weight provided to these misclassified entries, it is equal to previous weight. What was the previous weights given? 0.1 into e raised to the power this alpha m, which is 0.42. This, when you solve, you get 0.15. And that is how this 0.15 is appearing. Okay, these are the formulae which are used to help you arrive at this. This alpha m is called as loss function. For now, just remember that this is loss function. When we get into neural networks, right, I'm going to in detail explain you. But for now, just remember that this is called as what function? Loss function. Okay, this error is summation of weights of all the misclassified entries divided by summation of weights of all the entries. Summation of all the misclassified entries divided by summation of all the weights. That is this e raised to the power m. That is called as a term rate. This is called as term rate. And the weightage is nothing but old weight into exponential of this term rate. All right. So this is done. First part is done, iteration. You could figure out this. I'm removing because everything is given equal weight when you start the algorithm. Then these 3 were misclassified and you calculate. Okay, loss function term rate. Now you do the next classification. Say the next classifier let me choose a different. Okay. Say the next classifier turns out to be this. So this is part of what? Iteration 2. In iteration 2, anything which falls on the left side will be blue color. Anything which falls on the right side will be red color. I'll bring this line later. So what are the data points which are misclassified here? S6, S7, and S8. Because anything which falls on the left should be blue color. Anything which falls on the right should be pink color. Okay, iteration 2 is done. And then I got 6, 7, 8 as misclassified entries. But how are the weights changed? You need to give more weight, right, to those entries which are misclassified. So how would you calculate those? Now, here is the formula. Term rate is initial weights. Initially, what are the weights given to them? 0.1, 0.1, and 0.1 to both 6, 7, 8. 0.1, 0.1, 0.1 divided by the total weight. If I add all these weights, how much would you get? 1.15. And when you solve it, what do you get? 1.26. Since you get 1.26, you say that 1 minus 0.26, sorry, 0.26 divided by 0.26. When you solve it, you get 0.52. Then 0.1 into e raised to the power 0.52. How much would you get? 0.1. All right. Now what? That is the reason why we're giving a weightage of 0.17 to the misclassified entries. The weightage that you keep providing for the misclassified entries will keep on increasing so that the chance of they getting selected in the next algorithm is higher in the training data. Okay, done. Now the third classification, or third iteration rather. Let me remove this line. Let me ensure that I give you a third classifier, which is this. Okay. Say the third classifier is like this. Anything which falls below is pink. Anything which falls above is blue. In that case, what are the misclassified entries going to be? 1, 2, and 9. Why? Because if it falls below, it should be pink, but these are blue. If it falls above, it should be blue, but it is pink. So these three are misclassified entries. So for these three, now we need to give some weights. Again, what are those entries? 1, 2, and 9. What are the weights initially which are given? 0.1, 0.1, 0.1 divided by overall weights. So you need to add all these weights. When you add all these weights, you get 1.33. And when you solve it, you get 0.23. You take that 0.23 and substitute here in this formula. 1 minus 0.23 divided by 0.23. Okay, and how much are you getting here when you solve it? 0.62. Yeah, iteration 2 weights only will be taken for iteration 3 because you're looking at previously what were the weights, now what should be the weights. So here you give 0.62 and ultimately you get 0.19. So for all these misclassified entries, these three, you change the weights. And this is how the algorithm will continue on and on. And finally, you combine the results of all these classifiers. Now let me give you the initial classifiers also. This was iteration 1. And this was your iteration 2. And this was our iteration 3. Now, given these iterations, what happens is, if I were to combine all those three, what will be combined? This is how it will look like. Now look at the classifier. Okay, sorry, it will look like this. Come on. Okay, this was an orange, sorry, whatever line, and this was a black line, and we had a blue line, right? So when I remove this, this, and this, ultimately you get a classifier in such a way that none of the data points are misclassified. This is how you combine the results. Which is basically Adaboost is for classification only. Okay, and then when you combine all these models, right? If you look at this alpha, which is a loss function, this 0.62. After iteration 1, we got a classifier like this. And you know what? This alpha term was 0.42. That was a weightage given, multiplied by this, whatever is the classification result. Plus, when the second iteration was run, this was a classifier, and the weightage given for that, or the loss function, was 0.52 into this iteration 2. And when the third one was built, this is how the classifier was. And the weightage is 0.62. So 0.62 into this. When you combine these, you get a classifier like this. Simple. I'm just combining the results of all these three classifiers so that you get a final classifier. This is the reason why the algorithm is very good. It gives you good results. Now tell me, can I do parallel processing here? Can we do parallel processing? Why can't I do? Absolutely. If you look at this very, very clearly, the first iteration results 0.15, 0.15, the weightage determines what observations will be in training, what observations will be in test for iteration 2. And clearly iteration 2 results will be going as an input to iteration 3. Since this is the case, you cannot perform any parallel processing. Okay, so I'll erase this and let me go back to this. So initially you initialize all the training samples with equal weights. Then you generate a sample and train the model, that is a weak learner, base learner. Right. Multiple weak models, you're combining it to become a best model. That's what is the concept of boosting. So that's nothing but a base learner only. Then you test the model on the test data and get the misclassified samples. You assign weights for misclassified samples, which means you're increasing the weights for the misclassified samples. Then you repeat the steps. Then you combine all the results. Here are a few parameters. Base estimators, number of estimators, learning rate. Base estimator is decision tree with maximum depth equal to 1. Here, you only split it once in Adaboost. When you use a decision tree, right? You only split it once, job done. Again, split it once, job done. In iteration 3, only split it once, job done. You don't continue the split. Okay. Though you use a decision tree, it's a variant of decision tree, which is called as maximum depth equal to 1. So you restrict your depth. Okay. All right. Yes, exactly. After each iteration, weights change. Okay.